Welcome back to our channel. Today we are going to explain you about defect management. By seeing this video, you will understand process workflow for defect lifecycle, advantages of defect management tool, defect tracking phases and activities, defect status, defect reporting, defect resolution types, defect classifications, defect metrics, sample defects with severity level, and we have covered many more questions which will be asked during interviews. What is a defect? Defects are the gaps between the expected behavior and the actual behavior of the application. A defect that causes an error or negatively impacts a user or customer is categorized as failure. Defects arise from the verification and validation of the programming products like system requirement specification, test specifications, and code. Defect can arise in any of the software test lifecycle phase. Defects arising from each phase should be logged and tracked to closure. Defect lifecycle flowchart. Please have a look at the flowchart, which will help you to understand the defect management workflow. First, defect will be identified and logged by the tester. Defect priority will be set by the tester and defect severity will be set by the business team. Here the defect status will be open. Then the defect review will be done by the respective development personnel, and the development personnel will confirm whether it is a defect or not. If it is not a defect, then close the defect with appropriate reason. If it is a defect, then assign the defect to a developer. Once the developer fixes the defect, then change the status to retest or defect fixed. Then the tester will retest the defect. If it is as per the expected result, then close the defect. If it is not fixed, then defect will be reopened. Defect lifecycle detailed description. Defect lifecycle comprises different stages of a defect when it is tracked to closure. A sample defect lifecycle stage is given below. First, execute the test and compare the actual results to the documented expected result. If any discrepancy exists, log the discrepancy with the status of open. Supplementary documentation like screenshots should be attached for reference. Then, the test lead or tester should review the problem log with the appropriate member of the business team and also the documents available like system requirement specification and business requirement specification documents to determine if the discrepancy is truly a defect. Then, assign the defect to a developer for correction. Once the defect is corrected, the developer will usually enter a description of the fix applied and update the defect status to fixed or retest. The defect is routed back to the testing team for retesting. Additional regression testing is performed as needed based on the severity and impact of the fix applied. If the retest results match the expected result, then the defect status is updated to closed. If the test results indicate that the defect is not fixed, the status is changed to reopen and sent back to the developer. Defect management. The purpose of defect management is to plan and monitor the software defects and track them to closure. It involves recording of defects, classifying them and identifying the impact, collecting information about the type of defects and the phase at which the defects entered into the software, monitors the effectiveness of the various levels of testing. It is a common practice for software to be released with known bugs that are considered non-critical. Testing may provide a statistically reliable estimate of the number of likely bugs remaining. Most big software projects maintain a list of known bugs. This list informs user about bugs that are not fixed in the current release or not fixing at all, and often a workaround is offered additionally. There are various reasons for such a list, like the developers often don't have time to fix all the non-severe bugs, or the bug could be fixed in a new version or patch that is not yet released, or it may be like the changes to the code required to fix the bug would be large and would bring with them the charge of introducing other bugs into the system. Defect management tool. A tool that facilitates the recording and status tracking of defects and changes. They often have workflow-oriented facilities to track and control the allocation, correction, and retesting of defects and provide reporting facilities. Some companies use manual process like using Excel workbook, and some other companies use tool-based process for defect management. Tools available in the market like Bugzilla, Jira, Zoho, Teamwork, Issue Tracker are mainly used in most of the companies. Advantages of using defect management tool. Defect management tool provides better communication and teamwork. A bug tracking system provides better communication through chat interfaces and email notifications. This reduces the communication gap and informs the right person to test or fix bugs on time. The centralized data system provides access to real-time data that helps in attempting new bugs, exploring application, and preparing clear reports. It also saves huge cost and saves time also. Next, it helps in delivering high quality product. A bug tracking tool assures that detected bugs are fixed. It helps to remove flaws in the product by controlling the work of each team member. The system can track problems and analyze efforts taken by the team members to fix a bug or an issue. This results in delivering efficient product on time within a given budget. Next, it helps in creating trend analysis. The defect tracking process, like most other functions, draws pattern over time. Analyzing these patterns make it easy for developers and testers to respond quicker to frequently raised issues and use historic defect information to quickly arrive at root causes and determine the right course of action without unnecessary delays. The most obvious advantage is that it allows companies to keep a record of the bugs that are detected, who fixed them, and how long it took to fix a particular issue. Next, it helps in identifying areas of improvement. As a follow-up from the previous point, trend analysis also helps identify which areas are most vulnerable to errors and defects. Analyzing defect distribution helps identify which areas need attention and who among the development, testing, or deployment teams need training. Next, it helps in defect metric collection and automatic generation of reports. It helps ensure that bugs found in the system actually get fixed and also provide a way to ensure follow through, but also provide valuable metrics. The metric can be in the form of pie charts and also bar graphs. Next, notification or alert message to users on update. A bug tracking system allows end users to report issues and bugs directly on the application. Common issues can be analyzed and solved through product modifications. It provides automated response to end users. Users get updates and status of development through alerts. It also provides better and relevant service to customers by allowing them to share feedbacks and suggestions. Next, it helps in setting up of priority for defect fixing. Testers define which defects do not require much attention. This is why the bugs are prioritized to maintain a proper system for all defects popping up in the system. While development teams also need to ensure that they do not ignore any defects in the system. Next, it helps in traceability of defects with requirements. It provides valuable metrics that can tie defects to changed code or requirements, test or other data depending upon the tool that they are using. It helps in providing traceability or analysis on defect trends. If a particular module of software application is affected by defects, then it may be time to review and rewrite that module or specific part of the code. Next, improved return on investment. Priority issues are always evident when using defect tracking tools. Your development team will focus on essential areas and devote less time to low priority items, effectively reducing the cost of development and organizing the way the team works. Next, increased productivity. When all the team members are able to identify, track and fix the defects, they take ownership of the bug and are encouraged to do more of the same. It helps to monitor each other's achievements, promoting productivity and collaboration. And the last, it helps in data capturing. Data collected from the tracking process can be used to improve efficiency, eliminate bottlenecks, and be documented for future reference. Defect tracking phases and its related activities. First, reporting defects. The activity to be performed during defect reporting phase is enter the defect information in the available format in the test management tool. Next, in the defect tracking phase is setting of priority level to the defect. The activities to be performed during this phase are categorize the defect, then analyze the impact of the defect in the system, then set the priority level and pass it on to the development team. Next in the defect tracking phase is reviewing new defects. The activities to be performed during review of new defects are review of all new defects in the database to be carried out by project manager or project lead. Then they will decide what to fix. Then they will set the status of new defect to open. Then assign the task to a member of the development team. And the duplicate defects in the database has to be deleted or change the status to closed. Next in the defect tracking phase is fixing the open defect. The activities to be performed during this phase are: first, the developer will investigate the open defect. Then will identify the cause of the defect and modify or rebuild the application, and after the defect is fixed, will update the defect status to fixed in the system. Next, the defect tracking phase is testing a new application build. The activities to be performed during this phase are: tester will carry out a retest on the new build of the application after fixing the defect. If a defect doesn't occur, change its status to closed, and if a defect is detected again, change its status to reopen. Next, the defect tracking phase is analyze the defect data. Here, the team will prepare reports like how many defects were raised and how many are fixed, how many still open, and how many defects are reopened. Similarly, reports and graphs will enable us to analyze the progress of defects fixed and check how long the defects have been residing in the project database. This will help us to determine when the software can be released. Defect status in the defect management tool are system managed internally. New status. The tester provides new status while reporting for the first time. Open status means the developer opens the defect. Then rejected. Rejected means developer rejects if the defect is invalid or defect is duplicate. Then fixed. Here developer provides fixed status after fixing the defect. Then closed. Here the tester provides closed status after performing confirmation of retesting. Then reopen. Here the tester reopen the defect with valid reasons and proofs. Then not a bug or invalid. It means a bug can be marked as invalid or not a bug by the developer when the reported issue is as per the functionality but is locked due to misinterpretation. Then deferred. Deferred status usually when the bug is of minimal priority for the release, and if there is lack of time, in that case those minimal priority bugs are deferred to the next release. Then cannot reproduce. If the developer is not able to reproduce the defect raised by the tester, then it can be marked as cannot reproduce. Then duplicate. This means that someone else has already reported the problem. One way to avoid starting out with many duplicates is by reviewing the defects that are currently open. Mastering systems keyword searching capabilities is another way of avoiding too many duplicates. Normally, the defect management tool will have a field for the original defect number. The person marking the defect as a duplicate should fill in the number of the original to make it easy for others to go back, review the original and see if they agree. And the last is need more information. This means that the developers do not have enough information to understand or reproduce the problem. They should note in the defect what they are looking for. Defect report. Defect report is a document which provides a report on the count and severity of the defects at various testing stages. It acts as a dashboard for a test manager to assess the test progress and the software quality. Purpose of defect reporting. Defects are useful in correcting the software, in predicting the quality of the software, to gather statistics used to develop defect expectations in future applications, to take preventive actions like training, establishing methods and procedures, etc., and to improve the software development process. Key points to ensure effectiveness of defect reporting. Condense. The comments must be very clear and brief in the report. Accurate. The report should confirm that the raised defect is really a defect, or could it be user error or misunderstanding, etc. Neutralize. The report should mention just the facts, no humor or no emotion. Precise. Report the details specific to the defect, that is, explicitly what is the problem. Isolate. What has been done to isolate the problem that was raised in the report. Generalize. What has been done to understand how general the problem is. Recreate. What are all the essentials in triggering or recreating this problem, like environment, test steps, test conditions, etc. Impact. Report should point out what is the impact to the customer and what is the impact to the test. Debug. What does development need to make it easier to debug the defect highlighted in the report? It can be in the form of logs, traces, dumps, immediate access to the system and server, etc. And the last is evidence. What documentation will prove the existence of the error? It should be mentioned in the report very clear. Major reasons for defects. 1. Miscommunication. 2. Programming errors. 3. Timeline process. 4. Change in requirements. And 5. Software complexity. Defect log components. An ideal defect report should consist of the below details. Defect report should have a unique defect ID. It should provide a short name in 5 or 6 words for test case. It should ensure a short description of the bug in the defect report. Mention in which build the tester found the defect. Highlight the build version ID for reference. Ensure marking the feature, module and section of the application in which the error has occurred. Enter the date when the defect was identified. Tester name should be specified in the defect report so that developer can reach out for any clarification. Assign the defect to the responsible person in the development team, for example, to the project manager or project lead. Provide details on how to reproduce the defect. Ensure sharing the test data used during testing. Add any system setting details that could help in reproducing the issue. Provide test environment detail. Ensure providing the defect priority for fixing the defect. It can be high, medium or low. Ensure providing the defect severity for fixing the defect. It can be critical, major, minor or suggestion. Attach screenshots including timestamp along with defect details. Defect status. It should be new from testing team, then starts with open, assigned, fixed, retest, reopened, deferred, rejected, duplicate, closed, not a bug as status in the report. And the last one is resolution. The development team sets this field for marking the defect resolution detail after they fix the bug. Sources of defects. It is of two types. First one is defects from product specification and the other one is defects from customer or user expectation. Categories of defect. 1. Wrong or incorrect requirement. The requirements have been implemented incorrectly. This defect is a variance from the given specification. 2. Missing. There was a requirement given by the customer and it was not done. This is a variance from the specifications, an indication that a specification was not implemented or a requirement of the customer was not noted properly. 3. Extra. Additional feature included which was not requested by the customer. A requirement incorporated into the product that was not given by the end customer. This is always a variance from the specification, but may be an attribute decided by the user of the product. However, it is considered a defect because it is a variance from the existing requirements. Defect resolution types. A resolution for a defect raised can be in any one of the following below. 1. Fix. The developers think they have a fix to the problem. A field indicating which build the defect will be fixed. 2. Deferred. A defect is usually deferred when management or all parties agree that the issue is not drastic and can be put off until a later time. 3. Duplicate. This means that someone else has already reported the problem. 4. Need more information. This means the developers don't have enough information to understand or reproduce the problem. They should note in the defect what they are looking for. 5. Not a defect. The developers disagree that it is a defect. Another way of saying this is working as designed. 6. Not reproducible. The defect could not be reproduced. This may be either because there is something strange about the setup or the person looking at the defect is trying it in a later build. The defect may have been inadvertently fixed since it was encountered in the last build. However, if it can still be reproduced on the tester's machine with the later build, one should disagree, reset the resolution and talk to the developer. 7. No plan to fix. The defect has been recognized as a problem, but the developers don't plan to do anything about it. This is mostly seen when the product approaches its shipment date and the pressure mounts. If one has to disagree with this solution, one may need to escalate it for attention. And the last one is user error. The defect has been wrongly raised because of the incorrect way of doing certain things while testing the software. Define critical bug. A critical bug is a showstopper, which means a large piece of functionality or major system component is completely broken and there is no workaround to move further. Bugs which affect the customer's business are considered as critical. application cannot be distributed to the end client unless the critical bug is addressed. For example, due to a bug in one module, we cannot test the other modules because that blocker bug has blocked other modules. It can be like issues in sign-in page. Define reproducible defect. If a defect is appearing every time during execution of a specific scenario, then it is called reproducible defect. Define debugging. Finding and fixing bugs is known as debugging, and it has always been a major part in software programming. As software programs grow more complex, bugs become more common and difficult to fix. Often programmers spend more time and effort in finding and fixing bugs than writing new code. Usually, the most difficult part of debugging is locating the erroneous part of the source code. Once the mistake is found, correcting it is usually easy. Programs known as debuggers exist in helping programmers to locate bugs. However, even with the aid of a debugger, locating bugs is somewhat an art. It is not uncommon for a bug in one section of a program to cause failures in a completely different section, thus making it especially difficult to track. Typically, the first step in locating a bug is finding a way to reproduce it easily. Once the bug is reproduced, the programmer can use a debugger or some other tool to monitor the execution of the program in the faulty region and find the point at which the program failed. And it is not always easy to reproduce bugs. Some bugs are also triggered by inputs to the program, which may be difficult for the programmers to recreate. Defect severity classifications. Defect severity can be defined as the impact of the defect on customer's business. It can be critical, major, minor, or suggestion. In simple words, how much effect will be there on the system because of a particular defect. First, critical. Critical defect means a defect that impacts areas critical to the business and which stop the testing of substantial areas of the system under testing. Major. Major defect means that the defects that are serious problem whose impact is confined to a functional area and for which there is a workaround. Minor. Minor problem in a single screen are related to a single function for which there is a workaround. And suggestion. The requested changes can benefit the end user in terms of user friendliness. Defect priority classifications. Defect priority can be defined as how soon the defect should be fixed. It gives the order in which a defect should be resolved. Developers decide which defect they should take up next based on the priority. It can be high, medium, or low. Most of the times, the priority status is set based on the customer's requirement. First, high. High priority means the defect needs to be fixed as soon as possible. Further testing might not be possible or meaningful unless this is fixed. Next, medium. Medium means the defect needs to be fixed at the earliest opportunity available. The defect might be an obstacle for testing a section of the system. However, the testing of the rest of the system is not severely handicapped by this defect. Next, low. Low priority means the defect might be affecting only a minor section of the application, or overall testing is not severely affected by this. How will you relate severity and priority to each other? Severity represents the depth of the defect as per business. It describes the defect based on application point of view, whereas priority represents which defect should get fixed first. It describes the defect based on user's point of view. How the tester should deal with the reproducible bug. First, clear all caches and cookies and retest the test cases. Keep considering the other facts like test data, test environment, system settings, and screenshots. And once an issue is found, verify the same issue on different browsers, operating systems, different devices, which helps in determining if an issue is there in the system or in browser specific or device specific. How the tester should deal with the non-reproducible bug. First, check if it occurs when we restart the application. Then check the environment and inform about the issue to other team members and stakeholders. Define the bugs that come under the non-reproducible category. The following type of bugs come under the non-reproducible category. They are: 1. Defects observed due to low memory issue. 2. Issues raised due to address pointing to a memory location that doesn't exist. And 3. In certain conditions, an error scenario occurs when the timing of one event impacts another event when executing in a sequence. A tester can take the following actions to handle the non-reproducible bugs. 1. Execute the test steps that are close to the error description. 2. Evaluate the test environment. And the last, examine and evaluate test execution results. What will you do when a defect arises during testing? When a defect arises during testing, we need to follow the below steps. First, run more tests to make sure that the problem has a clear description. Then run a few more tests to ensure that the same problem doesn't occur with different inputs. And once we are sure of the full scope of the bug, then we can add details and report it. A simple question. During the testing of a module, tester finds a bug and assigns it to a developer. But developer rejects the same, saying that it is not a bug. What should the tester do? Re-execute the test case and reproduce the defect with screenshot and timestamp. Then share the details to the respective stakeholder.
Define showstopper defect. A showstopper defect is a defect which will not allow a user to move further in accessing the application or any other module. It needs to be fixed on high priority. It is very critical to the business to operate further. It can be called as hotfix defect. Example, the user is not able to log in the home page of the application, even though the user have a valid username and valid password. It stops the user from accessing the application. Here, the developer needs to give importance to fix it on high priority.
Define bug release. Releasing the software to the production environment with the known bugs and with the acceptance of the client, then it is called bug release. These known bugs should be included in the release note. These bugs are usually of low severity or low priority. Define bug leakage. When a customer or end user discovered a bug which can be detected by the testing team, or when a bug is detected which can be detected in previous build, then it is called as bug leakage. The earlier question can also be asked in this way. When an application is released with the bugs which should be rectified by the testing team but missed and found by the customer or end user is called bug leakage. Define defect age. Defect age can be defined as the time difference between date of defect detection and date of defect closure. Define defect tracking. Defects are tracked through a traceability that is established from requirements through design to testing. This traceability is the key for identifying root causes across the entire life cycle. The defect logging tool then maintains the entire life cycle of the defect from detection to closure. The generated defects data then becomes a part of a greater set of defect prevention processes. Sample defects with its severity level. The criticality of a defect can be low, medium or high depending on the context. For example, user interface defects will be categorized as low severity. Boundary related defects will be categorized as medium severity. Error handling defects will be categorized as medium severity. Login related issues will be categorized as high severity. Calculation defects will be categorized as high severity. Misinterpreted data will be categorized as high severity. Hardware failures will be categorized as high severity. Compatibility issues will be categorized as high severity. Control flow defects will be considered as high severity, and load conditions will be considered as high severity. Examples for bug severity and bug priority. First one is high priority and high severity. Submit button is not working on a login page and customers are unable to log in to the application. The second example is for high priority and low severity. FAQ page takes long time to load. Third example is for low priority and high severity. Crash in some functionality which is going to deliver after a couple of releases, and The last, fourth one is low priority and low severity. Spelling mistakes of a company name or a content on the application home page. Define defect detection percentage. The number of defects found during a test phase divided by the number of defects found during that test phase and any other testing afterwards. For example, defects identified during system integration testing divided by defects identified during system integration testing and user acceptance testing. It means that the efficiency of system integration testing team performance is good when the percentage is less, whereas if the percentage is higher, then the system integration testing team performance need to be improved. Define defect triage. Defect triage means the degree of urgency. It is one of the best way to prioritize defects based on factors like the risk involved, defect severity, and frequency of occurrence. The role of a tester is to prioritize and resolve the bug based on its priority. What are the two parameters that determine quality of testing? The first parameter is defect rejection ratio. It means percentage of defects rejected by development team that are raised by testing team during testing phase. The second parameter is defect leakage ratio. It means percentage of defects identified by end users or customer after system integration testing done by testing team. Define defect masking. An occurrence in which one defect prevents the detection of another defect in an application. Because of this, the impact might be severe in many cases. Define error seeding. It is the process of adding known defects manually to those already in the application for the purpose of monitoring the rate of defect detection and defect removal efficiency and estimating the remaining defects count in the application. Define defect cascading. If one defect is caused due to the occurrence of another defect, then it is called defect cascading. It will occur when the particular defect is not identified during the initial testing phase. This leads to increase of defect count in the later stage, which will cost higher to fix the defect and also time consuming. Define defect clustering. When defects are not distributed evenly across the application and identified in a specific part of the application, then it is called as defect clustering. It is related to Pareto principle. As per Pareto principle, 80% of the defects identified in 20% of the application or module, which helps the management to focus more on that 20% of the application to fix all the existing defects at the earliest. Defect density. It is the number of defects identified with a component or at the entire application related with the lines of code developed by the development team. It helps in understanding the capability and identifying the improvement areas of development team, like training to team members or upgrading the review mechanism, etc. It can be calculated as below. Defect density equal to total number of defects divided by number of lines of code written. For example, total number of defects identified is 10 and total number of lines of code is 10,000. then the defect density is 0.001. If we convert that into kilo lines of code, then it is 1 defect per kilo lines of code. This number is very good. We can conclude that the development team is very experienced. Whenever the defect density is higher, the rework will increase, which will impact both schedule and cost. Define latent defect. When a defect present in the system doesn't impact the application in the production and not identified in previous releases too, but it should be corrected as early as possible. Best example is date format February 29. February 29 comes only in leap year, that is once in 4 years. Only during the leap year, the system will look for 29th day in February. Else, it is only 28 days in that month. Defect will not be highlighted by the system as long as we are entering into the leap year. Hope this will help you to understand the meaning of latent defect. Defect metrics. We provided only the major list of metrics for your reference. First one, defect arrival rate in user acceptance testing. Here we will report the defect trend with their severity, priority and component wise. Next, list of open defects by age. We will report the list of open defects for severity 1 and 2 by defect age. Next, defect turnaround time. Here we will report the average time taken for defect fixing by support team. Next, defect holding maximum test cases. Here we will report the list of defects that are keeping maximum number of test cases are made, that is yet to be executed. Next, defect density. Here we will highlight the defects per unit size of the system. Next, pre-UAT effectiveness. It means the percentage of UAT defect with respect to total number of defects including UAT. Next, post-UAT defect arrival rate. It means reports rate of defect arrival in production. Next, defect detection efficiency. It means average effort spent to find a defect. Next, residual defect density. It means the number of defects while product in production for 6 months per product size. Why is it impossible to test a program 100% bug free? It is impossible to build a software product which is 100% bug free. You can just minimize the error, failure or fault in a computer program or system that causes it to produce an incorrect or unexpected result. Here are the two principal reasons that make it impossible to test a program entirely. 1. Software specifications can be subjective and can lead to different interpretations. And 2. A software program might require too many inputs, too many outputs and too many path combinations to test. In general, which testing phase contains more defects, test design phase or test execution phase? The test design phase is more error prone than the test execution phase. one of the most frequent defects which occur during test design is that the product doesn't cover the complete requirements of the customer. And the second one is wrong or bad architecture and technical decisions make the next phase, that is execution phase, more prone to defects. Because the design phase derives the execution phase. It is the most critical phase to test. The testing of the design phase can be done by good review. On average, 60% of defects occur during test design and 40% of defects occur during test execution phase. With this, we conclude our today's session on defect management. We will again connect with you very soon. Thank you for watching our channel.